let's take a look specifically at the hydrolysis of an ester, and we'll draw out the reaction and mechanism. So we have our ester in the presence of water with an acid catalyst. Now, if we're just trying to predict the product, I'm just going to draw water here close to the ester. And effectively, in the hydrolysis, you're breaking the ester bond, you're breaking the water HOH bond. And we're going to pair the hydrogen with the leaving group, and we'll put the OH with the carbonyl. So the products of this will have the carboxylic acid, and the alcohol. And you can see that the molecule in the ester gets broken apart, and we have the water broken apart, and the H and OH end up on the two components. Now, in terms of the mechanism, this is going to be familiar to other things we've seen. Just to make it a little easier, let's keep it generic, and I'm just going to draw a simple ester here. Right, in the presence of acid and water. So anytime you have a carbonyl in the presence of acid, remember our first step is protonating the carbonyl oxygen. So we'll protonate that. And we have a very familiar activated carbonyl. All right, now we have something that's really reactive, that can easily react with water, which is a weak nucleophile. So here's the water. Now it comes in and adds to the carbonyl. All right, we have our bond to water's oxygen, and that oxygen still has both of its protons on it. Remember, oxygen with 3 bonds, it has 1 lone pair and a positive charge. All right, from here, now what we're ultimately trying to do is we're getting rid of this O-methyl group. So what we want to do is basically turn that into the good leaving group in the mechanism. How do we make something a good leaving group in a mechanism? Get the proton to it. So we could do kind of the longer 2-step proton transfer where we bring a base in, remove this proton, and then protonate the oxygen. But let's just use a shortcut here. So we'll say our proton transfer shortcut. And we'll use the lone pair on this oxygen and grab that proton. So now this ether oxygen has 3 bonds and a positive charge. Right, that makes it a good leaving group, so it's going to leave in the next step. Now we could just break this bond and put a carbocation here, but it's actually easier to use one of the lone pairs on the oxygen and assist. So I can use this lone pair. I'll push that down, and that helps push away our leaving group. So we get the leaving group that's lost, HOCH3, and I have this protonated carboxylic acid. So now all that's left is to get that proton off of the oxygen. Any base in the solution can do this. So basically anything that has a lone pair. If you want to just be generic and use B, that's fine. Or if you want to be a little more specific, we could use water. There's a bunch of water around. That will grab the proton, leaving us with the neutral carboxylic acid. So we have ended up with our alcohol and carboxylic acid.